Guys, a quick point on chapter 5 again when you are replacing your support reaction with the relevant forces. So if you recall, remember when we replace fixed support, for example, this is just an example, we need to replace it with a force in the X, force in the Y, and a couple moment. Now, some of you have come to me and said, if I look here in this table, the force is going in the so-called positive X and the force is going in the positive Y, and I'm getting an anti-clockwise moment. But in this example here, they give me an anti-clockwise moment, okay, but then they change the AX to go in the negative X direction, but the AY, anyways, it's a confusion. What direction do I put the AX in, the AY, etc., etc. Guys, the basic idea is that if you have a fixed support, right, and you've got some forces acting on this, okay, and you want to replace that. Now listen carefully. You can choose whatever direction you want for those reaction forces. There's your moment about A, there's your forces, right? You can choose whatever direction you want. When you begin to solve the problem, you know, when you say sum of the forces in the X equals 0, then you've got AX and you've got this force, F1 plus F2, etc. I'm not sure what these are, okay? I'm just making this up. And you set that equal to 0 and you solve for AX and you get a positive number. Say now the number was 100 Newton. Say now we solved for AX and we got a positive 100. That means that the direction of your arrow was the correct direction. Okay? If you got AX equal to minus 100 Newton, then that means that your arrow was, you initially pointed the arrow in the wrong direction. So what that actually means is that the AX should actually be in that direction. Similarly, if you said sum of the forces in the Y equals 0, and you've got AY minus this force, whatever, plus that force, etc. in the Y direction, and you solve for Y, and you got minus 50 Newton, then what that means is you've chosen that arrow to be in the wrong direction. So essentially what this is just telling us is you've chosen a certain direction to be positive, and if you get a negative, then it means that the force is actually acting in the opposite direction. Okay? I've chosen a certain direction to be positive and I get a negative, for example. Guys, please don't memorize anything here. Just look at the principle. So say now I've chosen a positive Y direction. I've said AY is up, but then I get a negative. It means that actually AY is acting down. Similarly for the moment, right? The moment. I've chosen counterclockwise to be positive, so to speak. And if I get a sum of the moments about A or whatever, and I get MA is plus 150 Newton meter, then that means that direction of that arrow that is the direction of MA. MA is acting anti-clockwise. If I get MA is minus 150 Newton meter, then it means that actually the resultant moment is, or that MA is actually clockwise. Okay, let me show you one or two examples if I can find them. Here's an example of this problem here. It is example 5.5. You see there at point B. At point B, we replace that because it's a pin. We replace it with a BY and a BX. Okay. Now, we've chosen Bx to go in the left, towards the left, because the only other force we have acting is a 600 cos 45, which is the only other x force which is acting in the positive x. So it's pretty obvious that that B, there would be a reaction force that's opposing that force. So there we can choose Bx going to the left. So we've chosen Bx going to the left, and so we solve for Bx, and we get 424. That means that that arrow, the direction of that arrow is the correct direction, because we've said Bx is plus 424. It means the arrow direction is correct. But say now, guys, say now we had said Bx is acting to the right. To the right. Then we would have said 600 cos 45 plus Bx equals 0 plus Bx, because both these arrows would be going towards the right. But in equilibrium, obviously that doesn't make sense, right? So then if we had said Bx is going to the right, then Bx would be minus 424. If we had said Bx, the arrow is going to the right, then we would have calculated Bx to be minus 424, which means, oh, it's actually acting to that side. Similarly with By, okay? Where's our By? Nice. There it is, okay? We've got all these forces acting, and we say By, and we solve for By. But what we've said here is By is acting up. That's the direction of By. But we don't know, because we've got Ay, we've got that force, we've got that force. We're not sure if is By reacting upwards or is it reacting down. Well, we've chosen it to react upward, and we calculate By to be positive, which means that is the correct direction of the force. Okay? But if we had chosen By to be acting down, we would have calculated a minus 405, which means we just need to reverse it. Okay? So that's a good enough example for that. I tried to find some examples of where you get a minus, but here's an example of a moment. So remember this, it's like a sliding collar. If we replace this connection at point A with forces and moments, we're going to get something that looks like that, because it resists force in this direction, and it also resists a moment. But we're not sure, is this collar resisting a force in that direction, or is it resisting a force in that direction? Is the moment going to be clockwise, or is the moment going to be anti-clockwise? We don't know. It doesn't matter. Just put them in. And what you see here is when they solve for MA, they get MA is minus 1486 Newton, right? Do you see that? Minus. That means that that direction that we chose is wrong. It should be clockwise. So we chose an anti-clockwise moment direction, and we got a negative, which means actually it's a clockwise moment. So that is actually the wrong direction. It should be clockwise. Does it make sense? Similarly, let's look at AX. AX was solved where AX is 0. Okay. Because there's no force in the x direction. Okay. So that kind of forget the AX example there. It's just 0. But look at the moment example. The moment gives us a negative, which means it's going in the opposite direction. So I hope that helps, guys. Again, don't worry about the direction of the arrows. Just solve it. And if it's negative, it means your arrow is in the wrong direction. If it's positive, it means your arrow was in the correct direction.